Steel profiles are seldom used directly as they are bought from the rolling mills. More often than not, the profile ends will need to be cut, notched, coped, fitted, and sometimes openings need to be cut out from the webs. In COMOSYS you will find an extensive array of commands to make the tasks of cutting steel or concrete shapes easy. These can broadly be classified as polygon cuts, fittings, part cuts, and general parametric cuts. In this video we will be talking about polygon cuts. The polygon cut is basically an extrusion cut of a general polygon or a circle. Let's say we want to create a notch as shown in this figure. We start the command by clicking the polygon cut icon. A form opens up with an option to create a polygon cut or a circular one. Let's choose the polygon cut option. There is depth variable here which tells COMOSYS how much this polygon will be extruded on both the plus and minus directions of the plane created by the selected points. Enter a number which is suitable for the notch. Since we are trying to create a notch for the top flange here, with a notch depth of 40 mm, we can enter 40 here. Once we are happy with the settings, we press the Select Part and Points button. COMOSYS proceeds to ask us to select the part which needs to be cut. You can always look at the status bar below to read the prompts of various commands. After selecting the part which needs to be cut, the user needs to select some points. These need to be at least 3 in number. In our case we need 4 points. 2 are directly snappable on the part itself, and the other 2 can be snapped to using direct entry techniques. So no need to create these points. Just select them and then select the first point again to finish the selection. It is easy to imagine how this command can be used to make a hole in the web of the profiles, or for cutting basically any polygonal shape out of the material. As can be seen, an actual cut object with blue lines has been created by COMOSYS. This object can be selected and deleted if needed. The profile will back to its original shape. But more importantly than that, this cut object can be copied. So if we were to copy this cut object a distance of 1000 mm along the beam, we would create another cut object at that distance. The cut object can also be copied to a different part. For instance, if we were to copy it to this point, where a different I-beam is waiting, the copied cut object would find its new owner and attach itself to it. This feature of finding new objects to attach to is extremely powerful, and will be discussed in more detail in the video about copying, rotating, and mirroring objects. Now let's try the circular cut option. In this case, the user is required to choose 3 points. The first point represents the origin of the cutting circle. The second point represents any point on the boundary of the circle. while the third point will define the plane of the circle. There is also a section count here, which defines how accurate the circle will be. Usually a number around 32 gives a good result, but it should be noted that smaller numbers like 5 or 8 etc. can be used to create pentagons and octagons etc. Let's draw a polygon here by using direct entry method. If you want to create, the choice of P2 will also define the rotation of the pentagons or octagons etc. As always, we can copy these openings in the profile along the profile or elsewhere. Cuts are applied to the object in the order of creation. Deleting any will cause the whole object with all remaining cuts to be recalculated. Double-clicking on the cut object opens up its property window. In most cases, changing the properties of cuts is not needed, but there are a few properties of interest here. We have the name of the cut, and two extra fields called Info1 and Info2. The user can enter any text here. This text can then be annotated automatically in the drawings. So for instance, if you create a hole in a wall using a polygon cut, you can write window opening 800 by 1000 in this field, and then this text can be written next to the opening in the wall in the concrete drawings. One final point which is worth mentioning is this cut union property. Any cut can be converted into a union object as well by changing this property. Similarly, a union object can be converted into a cut object as well. Thanks for watching.